I should not have done anything to this. I should have just done eight.
Yeah.
What the world is that?
Okay, from your AP practice, homework from yesterday. On the key, I didn't fully finish the problem and I didn't show the work. So you guys had questions about that. Take a look at number 11. And then I'll come back in a second. I'll walk through the problem. Let's just take a look. I'm thinking.
Can we do yoga on the table?
Okay, so where did you want to put that?
I think I'm going to get some good things. It's kind of like what you don't put in.
But I don't have, we're not three months.
That's
Wait, I did this for so long. So like,
I say this. Oh, it's that's about it. That's what I thought. Yeah, that's what at least like, you know, I just trying.
Yeah.
And he just simplifies it because the context was simplified, but isn't that like y minus 2.0?
Sure, hope there's not
I
that.
don't just that.
You should watch,
But they should still, so every time it's flashed, it's actually moving this,
Yeah.
and every time it's
It's like.
vertical, it's painting.
Oh, I turn back in yard.
Yeah. Boom. We got this for so long.
So you know everything.
Okay, so let me walk through number 11 here. It says, which is the equation of the tangent line graph of curve, this polynomial, at the point where f prime is equal to 2. So, you know, whatever the graph looks like, just want to know whenever f prime is equal to 2, what is the equation of that tangent line that's going to skim the surface of the graph at x equals 2. Okay, this may not be exactly where that x equals 2 is, but I just want to kind of give you some quick connection as to what we're trying to find. Trying to find the equation of some line that skims the surface of the graph, wherever the graph has a slope of 2. So we know that this is the slope that we're after, and let's get these two to be at the same level in terms of the derivative. So I'm going to first find f prime. So f prime is 4x cubed plus 6x plus 0, because that 2 goes to a 0. I'm going to use a derivative to help me find the location of this particular behavior. I want to know, using the derivative function, when is the graph going to experience a slope of 2? So I'll replace 2 in for f prime and set that equal to 4x cubed plus 6x. But if I bring everything over to one side, even if I factor out the 2, I realize that this is tough to solve algebraically. We can't do quadratic formula, we can't factor. So we're gonna have to graph this, okay? And this is more of a like a AP style problem that is on the calculator section where we have to rely on the calculator for this. But we graph this function and then we look for the x-intercept. That is a way to find the solution with the calculator if we're not able to do it by hand. We simply look to see when is this graph going to cross the x-axis, and that's going to be our approximated solution. So if I were to graph it in the calculator and then look for that x-intercept will be 0.313. So that is the x value where this behavior is going to occur. So I know now my ordered pair is going to include 0.313. And to find the y value at that point, I'm going to take that 0.313, insert it back into my original equation. And then that's going to give me 2.304. Now I have everything that I need to build the equation of this line because I know the order pair. And I know the slope is 2. So then I can put that into point slope form. And then I'm just trying to match my answer choice. So I just added 2.304. I distributed 2 through, and then keep going until I match answer choice C. So today we're going to be talking about product and quotient rule. This is where we have combinations of different expressions that are being multiplied together, and we're trying to find a derivative or a slope formula for these combined expressions, or these expressions made up of combined parts. So let's go to page 22. So product rule says if I have the multiplications of two separate expressions, let's say there's an expression f and there's an expression g. If I want to find the derivative, I am going to have to involve f prime and g prime, but it's not quite as easy as just f prime times g prime. They're connected in ways that's it's a little bit more than that. So to find the derivative of something, of whatever this graph looks like, we have to make each kind of take turns with their derivative. So it's going to be f primes, or the derivative of f prime times the original g function plus the original f function times the derivative of g. So f prime times g plus f g prime. So after we go through that process, then whatever results is going to be the slope formula for whatever this original graph looks like. So something to be aware of is that a lot of these problems may require more space than what is given to you. So feel free to put that on a separate sheet if you're having trouble fitting all this. So I am going to put on a separate sheet just so I can have plenty of room here. So number 1 says find the derivative of each function. So there is a repeated notation here. This f is not the same thing as this f. So just know that this is the name of the function, but we're going to call the different parts of my function an f and a g portion. So we can clearly see that this is not just one expression, right? This is 8x times sine of x. Now, if it was just 8 times sine of x, then I can treat that coefficient as part of my sine of x, and there's no need to think of that as a separate expression. But as soon as there's multiple variables involved, I really need to think of this as the product of two expressions. And because of that, I'm going to assign each to be one to be f and the other to be g. It doesn't matter which one is which, but I'm just, whatever I see first, I'm always going to assign that as my f, and whatever I see second, I'm going to assign as my g. So my derivative, let me change this to y prime so we don't have duplicate variables making them confusing. I'm just going to label what I want to find. Okay, so I want to find f prime, and then I want to follow that up with a g function plus f g prime. So I'm just going to put in each space what is appropriate for the parts, and then that will give me the derivative of what I'm looking for. So 8x, what's 8x's derivative? That will represent f prime. Just 8. G function means we're just going to bring the g function down without making any changes. Plus, back to f, no changes. times G prime. So we do have to make an adjustment here. What's sine's derivative? And that is our derivative. So whatever we plug in for x, we're going to find the steepness of whatever this curve looks like at that particular point. Now, when you find your derivative, there's really no need to factor. Maybe down the line we need to, but for now, we'll just leave our derivative in whatever form, and that it will be sufficient. Okay, let's look at number 2. I'm going to get each term ready for, okay, so first of all, we see the need for product rule because 2e to the x is one term, root x is a separate term. They're being multiplied together. I'm gonna get each term ready for my next stage. I know 2e to the x is good. It's just that root x, I want to get it ready. What can I think of root x as? X to the 1/2. Yeah. So I'm now going to label each as f and g. Now, if you don't want to do all this, what I'm doing in terms of f prime g, you don't have to label that as I'm doing. I'm doing it so that it's clear for you. But if you're comfortable just writing the derivative and keeping track in your head what you need to do, that's fine as well. So I'm not going to take off points because you're not labeling everything. Okay, 2e to the x. What's 2e to the x's derivative? Same, right? We know e to the x is just e to the x. G doesn't change. F doesn't change. Okay, G prime. What's the derivative of x to the 1/2? Power rule, right? What's power rule? To the negative 1/2. So 1/2 minus 1. That's 1/2 minus 2/2, which is negative 1/2. The only thing I'm going to ask you with cleanup is just resolve the negative exponent. No need to worry about common denominator. I just wanted to yeah, that's fine. Or some variation of that. Okay, number 3. I could fold everything out and just rely on power rule, but we're just going to get practice with product rule. So now we would like to do power rule for everything, but something is a little bit not quite ready for power rule. What can we rewrite before we jump to our derivative? X to negative 1. Okay, so I'm just going to rewrite that. Yeah, I'm not gonna worry so much about any sort of a cleanup, as long as you have some, as long as your derivative is technically correct, and your negative exponent is resolved. Same thing on the AP exam. If there's true response and they're asking you to find the derivative, any variation of derivative is fine. There's we don't have to worry about, oh, I gotta clean it up, I gotta combine my terms. It's fine. Okay, number 4. Now, number 4 references a table, so we're still going to apply product rule, but we're going to use a table to make our substitute values for us. Anybody still need number 3? Okay, number 4. Okay, it says find h prime of 2. First things first, though. Let's find h prime of x. Let's find the derivative first, and then we can worry about evaluating that derivative at a point. Anytime I see a coefficient, I'm just going to let it attach itself to whatever comes first. So I'm going to call this whole thing, I'm going to let that 3 f of x be that first term, and then I'll let that g of x be the second. If you don't want to, it's fine. You can let that 3 hang out in front and then distribute later, but I just find it a little bit cleaner. I'm just going to let that 3 be part of f and g, so I don't have to worry about, if I forget about that 3 now, I may forget about later. So I'm going to let that 3 tag along and let that be with that. Okay, so now h prime. What's the derivative of 3 f of x? We just basically make it a function notation. We know f will turn into what? F prime, yeah. And the 3 just tags along. So if we have function notation to begin with, our derivative will just stay as function notation. Okay, g doesn't change. F doesn't change. Now g of x becomes what? It's g prime, yeah. We have our derivative. Go ahead and now replace every x you see with 2. And once you do that, then we can use the table to help get all these down to numeric values. Everybody okay so far?
Mhm.
Right, so now we go to our table and we just try to find the values that's associated. F prime of 2 is -2, g of 2 is -1, f of 2 is 4, g prime of 2 is 2. All right, anybody still need number 4? All right, number 5, same way. We see that there's a need for product rule because we have 2 separate expressions. I want to talk about, this is something that I see students stumble on. Anytime we see a denominator, I think the tendency is like, oh, what to do with it? Like, it just feels like something I haven't seen before. Anytime your denominator is just a constant, I like to rewrite it so that I don't have to stare at that number below in the denominator. So I'm going to force that out as 1/2, right? Divided by 2 is the same thing as multiplied by 1/2. So it just feels a little bit cleaner. If I pull that as 1/2, then it doesn't feel like, oh, I got to divide by 2. How do I do that? It just happens to be a fractional number in front. Like if it was a 3 or 5 or 6, we just treat it the same way. So that's my preference. Anytime I see a denominator numeric value, I like to push it out as a fractional number. Okay, we see a need for product rule. Let's go ahead and try that. What's 1/2 f of x derivative? What happens to the plus 2? The 0. Okay, I'm going to just leave it alone. I'm not going to put any number after that. What is 3? Okay, 3 minus g of x. It's just the same thing. Back to f. What's g prime going to be? Negative g prime, because that 3 goes to what? 0. Okay, so that's the hard part. Getting to the derivative. Now you're just replacing every x with -5 and then using the table to grab all your values. Okay, any questions? Product rule. Okay, let's go to the next page. Next up is quotient rule. Quotient rule is where I have 2 expressions that are divided by one another. And if I want to find the derivative, I am still going to involve f prime and g prime, but because they're connected by that division line, it's a little bit more than just f prime and g prime. So here's our rule. So I'm going to always call my top expression f, and I'll call my bottom expression g. So it's f prime times g minus f g prime all over g squared. So if you look, the numerator resembles a lot like your product rule. The only thing is that you're going to change that sign in between. So product rule is just f prime g plus f g prime. Quotient rule, keep the exact same pattern, just change that plus to a minus. And don't forget, we got to divide by the denominator square. So sometimes with quotient rules, some students forget to include this portion of the rule. So we're always dividing by the original g of x squared to completely build out our full derivative. So let's try a couple of examples. For one. Most of the time, you guys can just, leave it wherever you are. I just want to just practice cleaning this up, just to kind of show you what it could also look like. But careful though, whenever you get to this stage, make sure that if you want to clean this up, that you're doing it appropriately, that you're combining all your numerators together. We cannot do this. I know it's tempting. Why can we not just remove a 3x plus 1 and cancel these out? These look the same. Yeah, there's a minus. There's something else that's attached to it. Anything that's attached through multiplication, through addition and subtraction, we can't easily cancel out. Now, if this wasn't here, then that's fair game. You can start canceling those out. But as soon as you introduce anything attached with a minus or plus, you're kind of stuck. Unless you can find a GCF to take out of your numerator terms and turn it into a product, then you can cancel out. But typically, when you go through quotient rule, you have to clean up accordingly. We can never just cancel these out, even though it feels like we could. Okay, let's just try number 3. Okay, let's do number 3. We'll do 3 and 6, and then we can start looking at some applications. So try 3 and 6. Okay, does anybody still need number 1? I like for us to look at an application here. Can we look at page 25? And let's try number 19. Page 25, number 19. It says the graph of f and g are shown. If h of x equals 4f of x, g of x, find h prime of 1. Before we can find h prime of 1, we're first going to do what? H prime of x. Yeah, let's find the derivative function first, then we can worry about what to do with that 1. So what's needed if I want to find the derivative? Any special rule? Product rule. I'm going to let that f4 tag along with the f of x. So let's build out the derivative using product rule. Then we can see how we can use the 1 to help us get it down to a number selection. Okay. Now that I have my derivative, go ahead and replace every x with 1. So now we're going to use the graph to help pull these values here. G of 1 and f of 1 are just order pairs on the g and f function accordingly. What's f prime of 1 going to represent, though? We're going to be asking for the what of the f graph at 1? Slope. Yeah. And because these are nice diagonal lines, we can just count and do rise over run. It's not a curve where we have to, we're going to be, where we struggle, or we're not able to find the exact slope. But these are nice straight lines. We can just do rise over run to find the slope of each of the lines. F prime of 1, what's the slope of this close negative slope, right? Yeah, -1/2. So just pick any 2 points that lands on a nice intersection, and then you just count, right? Down 1/2. F prime is the slope of -1/2. G of 1 is asking me just for the y value of the g graph at 1. So g of 1 equals what? Negative. F of 1, we go to f of 1. We kind of make our best approximation here. Well, actually, we can figure out, right? We know it's going to go down by, the slope is 1/2. So what's that order pair there? 5. A g prime of 1, what's this? We know the slope of this line is going to be the same all the way through. So if we find the slope of this line, we can find the slope of the g graph at 1. What's the slope of my g graph? Yeah, 2, right? Pick any 2 points that are easy to identify and just do rise over 1, up 2 over 1. Okay, one last one I want to do with you, number 17. Okay, number 17. Same page. But first, any questions with 19? Seventeen reads, the function f is defined by f of x equals x over x plus 4. What points on the graph of f have the property that the line tangent has a slope of 1/9? So we know we're dealing with slope. We know we got to get to the derivative to be able to talk about slope or be able to connect something with slope. So let's find f prime first. So what would you use to find f prime? Quotient rule, yeah. Okay, so this is not my answer, but I know this is where I need to be to move forward with my problem. Any questions with the derivative function? So it says it's asking for what points on the graph have the property where the slope is equal to 1/9. So we're looking to see where on this graph is it going to experience a slope of 1/9. So how can we use this to help us find the location, given that we're after a slope of 1/9? What can 1/9 replace on this f prime? F prime is slope, right? So replace slope with 1/9. I can't put 1/9 in for x. That's a mismatch, right? 1/9 is not location. 1/9 is a slope. So we can ask the derivative basically saying, okay, I can give it a point and ask for the slope, but I can also go the other way around, ask the point given the slope. So I'm going to ask the derivative, or I'm going to give the derivative 1/9. I'm going to ask it, can you tell me the location that the original graph is going to experience a slope of 1/9? Right. So that's our algebraic step here. Cross multiply here. Take the square root. What's going to happen though if I take the square root of both sides of an equation? What's going to pop up? Plus or minus, yeah. So I got to do this equation twice, right? I have two separate solutions here. So there's an x plus 4 equals 6, and there's also an x plus 4 equals -6. So there's actually two locations on this graph where there's a slope of 1/9. Okay, so we're almost there. We know that there are two different locations where this graph will experience a slope of 1/9. And now the final part is, it says find the points, find the x and the y values. So how can I find the locations of the ordered pairs of the x? Plug it into the original. The original will give you location. The derivative gives you slope. So now we have to just make sure that we're calling and using a function and derivative appropriately. Okay, so if I plug 2 into the original function, I'll get 1/3. If I plug -10 into the original function, I'll get 5/3. So my answer choice C. Okay, check your calendar for homework. Come get your phones.
I think that's a